Enzymes. They're biological catalysts and a type of protein. All biological reactions are regulated by them. They're not involved directly in the reaction, but they drop the activation and energy barrier, making reactions more favorable to happen, and they make them happen more quickly. The speed of chemical reactions is determined by the amount of activation energy needed, the concentration and effectiveness of catalysts. Characteristics of enzymes. The shape of the globular protein determines the function. They stress chemical bonds like a tenderizer, and they lower the activation energy barrier. How enzymes work. Surface depressions are active sites and represent the location for catalysts. The substrate or reactant molecule in which the enzyme acts must fit the active site exactly. The enzyme stresses the chemical bond and therefore lowers the activation energy needed to break a bond. Factors affecting enzyme activity. Temperature and pH. Any changes in the above can disrupt the bonds of the protein and denature it, therefore changing the shape of the protein so it will no longer function. Most human enzymes work best at 37 degrees Celsius. Allosteric sites on an enzyme. They're receptor sites some distance away from the active site, and they bind substances to the enzyme that may either inhibit or substrate an enzyme's activity. Regulation of enzyme activity. Inhibitors. To inhibit means to stop. An inhibitor decreases the enzyme activity. The competitive inhibitor does not involve an allosteric site and are substances that compete with the substrate for an enzyme active site and block the substrate from binding. An example of this are beta blockers. They stop the heart from beating too quickly. For the competitive inhibitor, if the inhibitor beats the substrate to the enzyme, the substrate won't be broken down. The non-competitive inhibitor. Substances that attach to binding sites on an enzyme other than the active site. This causes a change in the enzyme's shape, therefore regular substrate doesn't fit. And you can think of this as the jaded girlfriend who finds out her boyfriend is cheating on her, so she changes the lock. The house is the same, and the door is the same, but when the boyfriend comes home to unlock the door, his key doesn't fit, because the active site is changed. Allosteric inhibitor. A substance that binds to an allosteric site on an enzyme and stabilizes the inactive form of the enzyme. The inhibitor binds to the allosteric site and changes the shape of the enzyme. This prevents the substrate from binding to it. And if the substrate can't bind to it, it won't be broken down. Activators. They increase the enzyme's activity because an activator binds to an allosteric site which stabilizes the protein conformation and keeps all the active sites available to their substrates. Both inhibitors and activators work because of allosteric changes of the enzyme as a result of the binding of a non-substrate molecule to the enzyme. Take note. Activator or effector stabilizes or activates the enzyme, allowing it to bind to the substrate. Cofactors, inorganic non-protein, and coenzymes, organic non-protein. They're needed for the enzyme to function and catalyze reactions. Cofactors are usually dissolved metal ions. Coenzymes include derivative of many vitamins. NAD+, or nicotinamide adenine dinucleotide, a derivative of vitamin B3. It's a redox molecule found in respiration. Many coenzymes shuttle molecules from one enzyme to another. Enzyme use in commercial and industrial purposes. Hydrolysis of starches into glucose, enzymes amylase and glucoamylase. Fat hydrolyzing enzymes. Lipases used by dairy industry to develop strong flavored cheeses. In the cleaning industry, we use proteases and amylases to help remove proteins and carb stains from clothes. And hydrolysis of lactose into monosaccharides. Because of lactose intolerance, enzymes used is lactase.